Welcome back. We're in lesson 18. We're going to talk a little bit about ratio word problems and similar triangles. So we know that a ratio can be written as a fraction, but what we have to do first is find the denominator before we can write it as a fraction. So if I'd said we had a group of red and blue marbles and we had 3 red to 4 blue in the bag, that means we have 3 red and we have 4 blue. Now, we can't say that we have 3 out of 4 representing the red. That's not exactly right, because the total number of marbles in the ratio is 7. We have 3 red and 4 blue. So 3 out of 7 are red and 4 out of 7 are blue. So you can see how that works. The whole set, the 3 to 4, is what we have to consider. You have to add one set and the other set, and sometimes you have a third set, in order to get the denominator for our ratio fraction. Now, many times people will say 3 to 4 and write it like this, and that's okay as long as you don't get confused and think this is the total number in the set, because it's not. I find it's easier to write a ratio with the colon in between so that it makes sense to me later that these are a set of numbers versus another set. So then that gives me a clue that I need to add them together in order to get my denominator for my fractional part of the total that represents. Okay, so for instance, my fractional part of red is 3 out of 7, and my fractional part for blue is 4 out of 7. So that is something you have to really think about when you're doing these. So we have a practice problem, 18.1, and I'm going to put that problem up here for you. All right, our problem states the ratio of Arabians to mixed breeds in the herd was 2 to 17. So let's write that part down, 2 to 17. If there were 380 horses in the herd, how many were Arabians? Okay, so we need to create a fraction that represents the part of the herd that was Arabian. Now, the total units that is being represented here, we have, for every 2 Arabians, there were 17 mixed breed horses. So that means in this ratio there are 19 parts, because 2 plus 17 is 19. So 2 out of 19 horses were Arabian, and that number 19 includes the 2 that are Arabian, right? You can see how that works. So if we had a total of 380 horses, how many were Arabian? Well, if 2 represents the part that are Arabian, then X is going to represent the part of the total herd. And if 19 represents the total of the 2 ratios added together, then 380, which represents the total herd, should go in the same location that 19 does. So there is a equality here. This fraction is a scaled up version of this fraction. So this side can be multiplied in order to be equal to this side. It's just like if we were to write 3/4 equals 15 over 20. That's correct, because 15 is 3/4 of 20. We scaled this up by a factor of 5. So that's what this is asking. This is what it's illustrating. It's saying to us that 2 out of 19 is the scale factor, or it is the scale, the ratio of the herd. What is the scale factor? How many were Arabians? And let's see if we can find that number. One of the ways that you could find that number would be to take 19 and just multiply it until you found the number that equaled 380, and then that would be the number that you would multiply 2 by to get x, there's a faster way to do it, and that's through division, which is the reciprocal of multiplication, which makes sense that it would be the way to find out what that answer is. So what we're going to do is cross multiply these two fractions to find that scale factor, and then we know the value of x. So we're going to start with our numerator and say 2 times 380. And then we're going to multiply our denominator times the numerator on the other side. That's going to be 19x. Okay? So this one times that one, and this one times that one. Keeping them equal to each other. And this is going to be 760 equals 19x. And we know now all we have to do is divide both sides by 19, because 19 times x is 760, right? So to find x, we just divide. This cancels, and this is 40 equals x. So there were 40 Arabian horses in the herd of 380. So our scale factor is 20. We can see that by dividing 40 by 2. So we put 40 here. If we were to divide 40 by 2, it would be 20. And if we were to multiply 19 by 20, we'd get 380. So that's our scale factor. We have 20 sets of 19 in this herd. All right, let's look at 18.2. It's a little bit different. Let me put this problem up here for you. So in this problem, we're looking at a compound that was made, and we need to know how much of other materials would be needed to make more of the new compound. So let's look at our components. We know we have 600 kilograms of sulfur, right? And we have 3,000 kilograms of the new compound. We'll just call it NC. So given that these compounds are static, meaning that they're not absorbed or changed, we can subtract 600 from 3,000 to see that 2,400 kilograms is needed of other materials to add to the 600 kilograms in order to make 3,000 kilograms, right? So it's a ratio of 600 kilograms to 2,400 kilograms, or you could reduce it by 100 and say 6 to 24, which you could reduce even more because 4 times 6 is 24, and you could say it's a 1 to 4 ratio. So there are 5 parts within this compound. Sorry about that. I needed to pause and clear my throat. I'm just getting over a cold. Okay, so we can see that the difference here is 600 to 2,400, which equals the 3,000 total. So it's kind of nice of them to give us the total so we didn't have to make that connection ourselves. All we had to do was find the difference in order to find the other materials. So now they're asking us how many of the other materials would be needed to make the 4,000 compounds. So all we have to do is set up our fraction of the other material total over the total of all the materials, and then put in our new total of all the materials and solve for x. Pretty easy peasy. So that is going to be, that's a pretty big number. So I think what I'll do is pull up my calculator on here so you can see what I'm doing. It just makes it a little bit easier to do. Okay, so we're going to do 2,400 times 4,000 because, again, we're going to cross multiply this side, right? And that is going to be 2,400 times 4, 1, 2, 3, thousand. Oh goodness, and that's 1, 2, 3, 4, 5 zeros and a 96. So let's write that down. 9, 6, and 1, 2, 3, 4, 5 zeros. That's 9,600,000 kilograms of something. And then we have 3,000 times x. And we know we have to divide both sides by 3,000, right? So we'll pull our calculator back up, and we'll just divide this number by 3,000, and that's going to equal 3,200. So 3,200 is the total kilograms of other materials that are needed to make 4,000 kilograms of the new compound. All right, everybody see how that works? It's all about knowing how to set up this fraction and what number goes where in the other fraction. Okay, if you're given the total, then the x goes on the top. If you're given the part on the top, then the x goes in the denominator where the total would go. All right, so let's move on to talk about similar triangles. And similar triangles, we're going to talk about scale factors. Remember we did scale factors a while back, lesson 14 or 15, something like that. So when we talked about transversals and similar angles. So now we're going to talk about similar triangles. So let me clear the page, pause and take notes if you need to. And let's jump right into 18.3. All right, so we're going to draw a triangle here. See if I can make it look pretty good. All right, there's a triangle. And it is not a right triangle. It's a little bit off. So there's that. All right, let me see if I can copy and paste that over. Nope. All right, so I'm going to highlight this one and I'm going to copy it. And I'm going to come over here and I'm going to paste it. And I'm going to make it just a little bit smaller. There we go. Now you can see the difference, right? This one is just a little touch smaller than this one. All right, so we have the measurements on this triangle given to us, but we only have this side right here given to us, and then this side is y and this side is x. But we know, we are told that this angle is congruent to this angle is congruent to this angle, and you can see the number of tick marks that I'm using. That indicates what it's congruent to. These three angles are identical, which means that the scale factors between the two will determine the lengths of the other sides. They have a corresponding relationship. All right, so in order to find your scale factor, you have to multiply this, and you're going to use the side that has all the measurements. You're going to multiply that times the scale factor, and you're going to this side, so that's going to be 3. So this is the 4 from this side and 3 from the corresponding side, okay? So 4 times the scale factor gives you 3, right? So treat this like a variable, and we divide both sides by 4, right? So the scale factor is going to equal 3 over 4. That's our scale factor. Excuse me. I still got a frog in my throat. Now, in order to find x and y, all we have to do is multiply the corresponding side that we have the measurement for by the scale factor. So in order to find x, we're going to multiply 5 times our scale factor. So 5 times 3 over 4 is going to equal x. We make this a fraction by putting 5 over 1, and then we multiply straight across. So it's going to be 15 over 4. That equals x. So that is the length here. Now you could break that down into a decimal or a whole number. If you wanted to, you could say, well, we know that that's going to be 3.75 here of whatever that is. It could be inches or whatever, because 15 divided by 4 is 3 with 3 left over, and 3/4 is 0.75, right? That's our decimal for that. So let's do this length here, which corresponds to side 7 in the larger triangle. So we multiply 7 times the scale factor of 3/4, and that's going to equal y. We put that over 1, make it a fraction. So 21 over 4 equals y. We could reduce that and say 5 1/4, just like we said over here, 3 3/4. And we know that 1/4 is 0.25, so we could say this is 5.25 if we wanted to. Or we could leave it at 5 1/4. We could say 5 1/4 inches and 3 3/4 inches if that was the unit of measure. So that is how we would use scale factor in order to find the sides. The thing to remember is you take the triangle that has all the degrees or all the lengths measured out, and you multiply that times the scale factor of the sides that are congruent, and then set that equal to the side in the triangle that you need to find the measurements for. So in this case, 4 and 3 were your similar sides. So 4 times the scale factor equals 3. And then you divide, and then that's your scale factor. Okay? So if you have any questions, feel free to message me, and I will see you in lesson 19.